Hello everyone, welcome. It is our pleasure to welcome Professor L. Sriramkumar at IMS. Okay, so I'm starting again. Hello, welcome here. It is our pleasure to welcome Professor L. Sriramkumar at IMSC for the Heritage Lecture as a part of our year-long program to celebrate both the completion of the 60 years of this institute and 75 years of India's independence. Professor Sriramkumar is a professor at the Department of Physics at IIT Madras. He is an expert in the fields of gravitation and cosmology. It gives me an extra ounce of joy to introduce him as today's speaker, as he was my doctoral supervisor at HRI, the Harishchandra Research Institute. Professor Sriramkumar did his PhD from IUCA, Inter-University Center for Astronomy and Astrophysics, Pune, under the supervision of Professor Padmanabhan. After that, he has worked at the Hebrew University, Jerusalem, Israel, University of Alberta, Edmonton, Canada, and at the Harishchandra Research Institute, Allahabad. As a postdoctoral fellow, he then joined HRI as a faculty member and later moved to IIT Madras, where he has built a group of gravitation and cosmology. And he is constantly working towards building Chennai as an important node of cosmology by connecting the efforts from different institutions. He's going to talk about the life and research of his PhD supervisor, Professor Padmanabhan, who is most commonly known as Paddy. Last year in September, we were shocked by the untimely passing away of Paddy, which created a void in the astrophysics community. From our student life, we knew Paddy as a legendary researcher in astrophysics and as a great teacher. Today, from Professor Sriramkumar's lecture titled Forces of Nature, Padmanabhan and Gravitation, we are eager to learn a lot more about him. Given Professor Sriramkumar's long association with him as Paddy's student and later as his collaborator and friend, I do not know anyone else who can illuminate us better. So therefore, without further delay, I would like to request Professor Sriramkumar to take the stage.
Thank you, Dheeraj, for your kind and generous words. I should begin by thanking Professor Ravindran, Professor Arijit Samal, Professor Dheeraj Hazra for the invitation to give this talk. It's indeed a great pleasure to speak about Professor Padmanabhan, Professor Padmanabhan, affectionately known as Paddy, as Dheeraj mentioned. I've been very fortunate to have exceptional mentors. There are two challenges when you have exceptional mentors. There are two sides. On one side, you have the privilege of access to them, to exceptional minds. On the other, it's a challenge. These are big shoes to fill. I was fortunate to have Professor Padmanabhan, or Paddy, as my thesis supervisor. His passing away, as Dheeraj mentioned, about a year back, has left a void in some of our lives who have known him very closely. I will forever miss him. It gives me great pleasure in talking about Paddy's life and his achievements. I sincerely hope I will do justice to his accomplishments. Here's an outline of my talk. I will start with a personal and academic history of Professor Padmanabhan. I will hereafter refer to him as Paddy. And then I'll spend some time reminiscing about some events, about how Paddy particularly influenced me. Then I will go on to highlight his significant contributions to research. This is a major challenge for me. It is like the proverbial behemoth and the blind men. Just that you need quite a few blind men to grasp Paddy's achievements. I will try my best. I have divided it into two parts: early years, intermediate years, and later years. And I will largely focus on his work in the context of gravitation. He has done a lot of work on aspects of astrophysics, touching on cosmology. I will touch on some aspects of cosmology, but it will largely around quantum field theory, revolve around quantum field theory and gravitation. And I will finally close with some broad remarks. Let me start with a brief personal and academic history of Professor Padmanabhan. This is a picture from this magazine, Mathrubhumi. It's a Malayalam weekly. This was published on September 19, 2021. Paddy passed away on September 17, 2021. And this was to celebrate his winning the Kerala Puraskar and lifetime achievement of the government of Kerala. That's the picture from that magazine that appeared on this day. He was born in Thiruvananthapuram. His date of birth is March 10, 1957. And his parents here, the picture taken from this weekly, were Lakshmi and Thanu Iyer. Thanu Iyer had worked as in the forest department of the government of Kerala. He had some interest in math, which he passed on to Paddy. Paddy's early education was largely in Thiruvananthapuram until he moved to TFR, Mumbai. He had completed his schooling at the government Karamana High School in Thiruvananthapuram. In those days, you had a 2-year pre-degree after you do this, you complete your 10th standard, which he had done at this government arts college in Thiruvananthapuram. And then he gone on to do his BSc as well as his MSc in physics at the University College, which is a part of Kerala University, again in Thiruvananthapuram. And the source for this is a lovely article by Jasjit Bagla and Sunu Engineer, which has appeared in this book titled, it's edited by Bagla and Engineer, Jasjit and Sunu, titled Gravity and the Quantum. In this article, they clearly mention, Paddy has also repeatedly mentioned, as to how these 4 textbooks, these 3 sets of volumes, and the book on gravitation by Messner, Thorne and Wheeler, MTW, this big black book, had considerably influenced his learning of physics. He had started with Berkeley physics course, and then, with Feynman lectures, and Landau-Lifshitz played a significant role. Later, as I will describe, some of the textbooks he wrote, particularly the series on theoretical astrophysics, he tried to emulate what was, the style of Landau-Lifshitz. And in fact, Mr. Thorne and Wheeler's book on gravitation again played a significant role in him learning gravity. I recall mentioning Paddy repeatedly as to how in those days he used to extensively copy down. There was a book in the library, there was no photocopies possible, and he used to copy down literally handwrite hundreds of pages of the book and work after working through them. This was the first paper of Paddy, which was written in 1977 as he was completing his BSc. And this is what he does, is that he tries to construct solutions of scalar and electromagnetic wave equations in a gravitational and electromagnetic waves. He was particularly proud of this paper he had written as he was an undergraduate student, and this was published in Pramana. Sorry, I went too far ahead. Once he completed his MSc, he had done well in NTSC and so on, but he couldn't really stay away from home. But then he was selected as a doctoral student at the Tata Institute of Fundamental Research, Mumbai, and where he could get a stipend and support his family to some extent. And then it became, there were some crises, and it became important for him to be able to support the family more. And he actually got a position as a research associate, few months into he taking up, he joining the Tata Institute as a doctoral student. Virtually, it was a position somewhere in between a student and a faculty. And around this time, he went on to complete his thesis on quantum cosmology, the path integral methods, applying path integral methods to quantum cosmology under the supervision of Professor Jayan Narlikar. He was a faculty at the Tata Institute of Fundamental Research until 1992, and it was in 1992 when he moved to IUCAA. I remember this because I joined IUCAA in 1992. On August 5, 1992, both of us went to Chella, if you know Chella, at IUCAA, to sign our joining reports. And then he has been a faculty at IUCAA since he passed away last year. As Paddy himself describes in his webpage, he has been primarily interested in these three directions. He has been, I should mention, this is very simple way of expressing interest. He has been working on very many aspects and very many directions of physics. But it is fair to say that most of his significant contributions have been in these directions, particularly on the interface between quantum theory and gravitation. And of course, he has made significant contributions to cosmology, structure formation, and even various aspects of astrophysics. These are his doctoral students. He had 16 doctoral students, direct students. And he had a couple of other joint students. He had co-supervised, he had contributed significantly. And most of them, apart from a couple of them, are faculty members at one or the other institutions across the country. Paddy, as you know, has written many books. And even as he was completing his thesis, along with Professor Nalika, he had come up with this book titled Gravity, Gauge Theories, and Quantum Cosmology, which constitutes much of what he had worked through as part of this PhD dissertation. I remember as he was moving to IUCAA, he had completed this book on structure formation in the universe, which had become an instant hit. This was 1993, which was followed by the book on cosmology and astrophysics through problems. This is inspired by the famous book by Lightman Price and Theokolsky on the corresponding problem book on gravitation. And then he had the first 3 minutes, which, as you can imagine, after the first 3 minutes, which is in some sense a follow-up of Weinberg's The First 3 Minutes. And then came this magnum opus, volumes 1, 2, and 3 of theoretical astrophysics. I will comment briefly about it as I go along, because this is something I have read through to some extent as I had to teach courses in astrophysics at HRI. And then which was followed by a brief invitation to astrophysics, which was published by World Scientific. And later he had the book on quantum themes, the charms of the microworld, published by World Scientific. Then again, something which is inspired by Landau's Lifshitz classical theory of fields and MTW's gravitation, which were in some sense, try to modernize those ideas in Paddy's own words. I will quote a reviewer as we proceed with the slides. This is Gravitation, Foundation, and Frontiers. And then he had these books on quantum field theory, on theoretical physics and quantum field theory, Sleeping Beauties in theoretical physics, and quantum field theory, why, what, and how. And his last book was with his wife, Vasanthi Padmanabhan, which is titled The Dawn of Science. Paddy has won many awards and distinctions. Notably, he won the INSA Young Scientist Award in 1984, the Birla Science Prize in 1991. I will refer to this prize as we proceed. It has some implication for me. And he won the Shanti Swarup Bhatnagar Award in 1996, the Millennium Medal of CSIR in 2000. And then he was very proud of this Sackler Distinguished Astronomer position at the Institute of Astronomy, Cambridge, and the Al-Khwarizmi International Award given by Iran. And then he went on to win this Homi Bhabha Fellowship and the Muguna Fellowship of the University of Melbourne, the Padma Shri in 2007, the INSA's Vainu Bappu Medal in 2007, and importantly, the first Gravity Prize in the Gravity Essay Contest. You will get to see that he has won, either any prizes between the first prize and the fifth prize in the Gravity Essay Contest, if I recall right, 8 to 10 times. mentioning the Lifetime Achievement Award of the government of Kerala, Kerala Shastra Puraskaram, which is when Malayalam Manorama, after he winning the award, they had interviewed him. Just 2 or 3 days before he was passing away, he had passed away, he had shared this article with me, requesting me to forward it to other Malayali friends. And he held quite a few important visiting positions abroad. He was a senior visiting fellow at the Institute of Astronomy. I had mentioned about his Sackler Distinguished Astronomer Award earlier. And he was a visiting faculty at Princeton, Pennsylvania State University, Caltech. He was there a few times. And then again, he was a visiting faculty at the Institute of Astronomy. I mentioned about the Sackler Distinguished Astronomer Award, where he visited a few times. And then, more recently, in 2018, he was at the Poly Center for Theoretical Studies as a visiting professor. So that's roughly a recap of Paddy's contribution, so to say, and and his accomplishments. So let me move on to some personal reminiscences. This was a picture. I mentioned he won the Birla Science Award in 1991. So this was announced, I believe, if I recall correctly, in late 1992. And we were going to for a party. This is actually in Paddy's lawn of the Paddy's house, and we had gone to his home, and we had prepared this, to celebrate his winning the award. And I recall what Paddy had done. I had joined him as a graduate student in August of 1992. And what Paddy had done was that he had given me a list of problems. In those days, LaTeX was still not very common, so he used to handwrite them. He had a few pages of problems. It's a natural follow-up of what his earlier students had done. Earlier students were T.P. Singh, who was until recently at TIFR, and Seshadri, who is at Delhi University. And I was able to solve some of the problems. I was having difficulty in solving some of them. I recall this day because I had spoken to him about this earlier in the day, and we were to go for this, celebration at his home in the evening. And I had told him, look, Paddy, I'm able to solve these problems. He said, yeah, I have solved them too. And then he said, I'm having difficulty with solving these problems. And I recall him saying, I asked him, can you give me a problem which I can solve? I recall him saying, if I have a problem and I can solve it, why should I give it to you? If I tell my student, they are rather unhappy with such a statement. But it took me aback initially, but it allowed me to be considerably independent. And amazingly, what Paddy will do is that if you have your own idea, he will support it to whatever extent to its full. So I think this comment very early in my as a doctoral student sort of strengthened me to face difficult challenges. The second thing was, Paddy was very sharp, very brilliant. If you have interacted with him, it is difficult to keep up pace with him. So this was my first paper. I was struggling for more than a year about understanding what are known as the response of untrue detectors. I will make a few remarks about the physics. So you may have heard about the untrue effect. What happens is that if you are in an accelerated frame and you try to see what is the number of particles in the Minkowski vacuum, you'll find that they are non-zero. In fact, interestingly, it's a thermal spectrum of particles. One of the notions that was introduced by Andrew and Devitt was the idea of detectors. What you have in mind is a point particle like an atom. It's a two-level system. And you set in motion along the accelerated trajectory. And it is interacting with the quantum field. And you try to see what is its response because of the interaction. What you essentially have to calculate is the Fourier transform of the two-point function of the quantum field along the trajectory of the detector. That's all you need to do. And so that's what this quantity here is, this f of t that appears here, f of omega comma t. Omega is the difference in the energy levels of the detector, And tau is the proper time of the detector. This is essentially a Whiteman function evaluated along the trajectory of the detector, and you need to Fourier transform this. Does it remain thermal, etc.? And we found that one encounters divergences. There is no divergences when the detector is switched on forever, but when you turn on and turn off, there are divergences. And in the literature, people had studied detectors which are turned off and turned on abruptly. What it means is that you essentially integrate, instead of minus infinity to plus infinity, some minus capital T to plus capital T. And they had encountered divergence. We could not figure out the origin of this divergence. What I had done, at Paddy's suggestion, was independently evaluate for some so-called window functions which were smooth. So we had this result where it was diverging only for certain types of window functions where the detectors were switched on abruptly. And it was Paddy who actually gave this proof that appears here in our paper, who showed that if the window functions are turned on and off abruptly, you encounter divergences. That is what we actually saw. And for a long time, I had difficulty resolving this, understanding this issue, and it was essentially Paddy's sharpness, Paddy's brightness, Paddy's intuition that helped me resolve this difficulty. Paddy was exceptionally well read. Two things stay in my mind. One, these two books, it was Paddy who introduced me to. You got to read Creations, Gore Vidal's Creation. And it reflects Paddy's outlook. I should narrate about what the story is. It's about a person by name Cyrus Spitama, who is, one half Persian, one half Greek, and he's a Persian ambassador to Greece. And he's, narrating about some historian. By the way, that historian is Herodotus. Reading about and referring to something known as the Persian Wars. Cyrus Spitama's Pay, well, I would refer to them as the Greek Wars. So this is typically how Paddy viewed, a very different view. He would quote this, and for me, it reflects the manner in which Paddy viewed various things. Another book he introduced me was Will Durant's Oriental Heritage. And I recall him quoting this particular paragraph which appears, when Will Durant writes about India. I will let you read that paragraph. And Paddy only had Will Durant, this is the first volume of a 10-volume book on the story of civilization. There was one book on Oriental heritage, the rest of them were about the West. Paddy had only this volume. And I remember he had, he had high views of the book, and it encouraged me to read it as well. So Paddy had a somewhat different outlook about various things, and which are reflected in some of the thoughts associated with these books. Now I move on to Paddy's significant contributions to research. As I already mentioned, this has been a major challenge for me for two reasons. One, lack of time. Paddy has done carried out a stupendous volume of work, and I will not be able to cover it within a limited span of time. The second is my own limitation. I don't understand everything he has written. I'm able to grasp a fraction of them very well. So the selection of the papers which I've tried to highlight work done and the results obtained in these directions, by just essentially highlighting the abstract of some of these papers, of the papers that has appeared over these years. And the division into early, intermediate, and late years will become clear. The reason for this division will become clear as I proceed with the arguments, with the presentations of the various results. I should clarify that this division is not, there is nothing sacred about it. It is something I have thought of, and there can be different interpretations of it. Let me start with his early years. As I already mentioned, his thesis was in the direction of quantum cosmology, particularly a path integral approach to quantum cosmology. And a few years after, towards the end of his thesis, he and with Jayan Nalika wrote this review, which has appeared in Physics Reports, on quantum cosmology, understanding quantum cosmology through path integrals. And one of the important results they had obtained was the following. What he had done, what Paddy had done, was that he had quantized the conformal degrees of freedom. He had taken a metric, typically a Friedman universe, and what he and you can show that the singularities such as the Big Bang can be avoided. The probability of having such a singularity essentially becomes extremely small. This was one of the early non-trivial results. Another result which Paddy was exceptionally proud of was, this paper. We will discuss about different aspects of this result as we proceed. Was this paper where he discussed the physical significance of Planck length. What we are interested in is the impact of Planck length on quantum field theory. So is there some way, you can show that once you take into account the quantum gravitational effects in some manner, there will be a Planck length that will appear, and whether they will help you regulate the divergences that otherwise arise. Again, using this method of conformal fluctuations, what he had taken is that, for instance, you can consider flat space, you can introduce conformal fluctuations, and you can integrate out the conformal fluctuations, and you can calculate the corrections to the propagator. For instance, if you have a massless propagator in flat space, as you know, it will be 1 over sigma squared, where 1 over sigma squared is the Lorentz invariant interval between 2 points in space-time. What Paddy had shown in this paper was that it will be essentially replaced in 3+1 dimensions by 1 over sigma squared plus LP squared. So as a result, in the limit, in the coincident limit where the 2 points, where the 2 space-time points merge, you still have a finite value for the propagator. And essentially what he had shown is that you can consider, you can expect quantum gravitational effects to act as a regulator at very short distances. Another point was related to the Unruh effect that I had mentioned a few slides ago. I had mentioned as to how, if you have an accelerated observer, the observer sees the Minkowski vacuum as populated by a thermal distribution of particles. And what you need to do to carry out quantization in a non-inertial frame is you need a time-like killing vector in your new coordinate system. Accelerated frame, in an accelerated frame, you do have a time-like killing vector. It is then interesting to ask whether there are other non-inertial coordinate transformations. You know that under Lorentz transformation, the notion of a particle is invariant. What one means by a particle in one frame will be the particle in another frame. The momenta and the momenta and energy may be different, but there will still be one particle. But not so when you carry out a general coordinate transformation. The classic example is that of the accelerated coordinate system. What Paddy had examined in this is whether there exist other non-inertial frames where you have a time-like killing vector, and if you carry out the quantization in those frames, whether there is what is referred to as an inequivalent quantization, whether the particle definition ceases to be coordinate invariant. So he constructed a variety of coordinate system. He carried out standard coordinate quantization in these frames, and also studied the response of these Unruh-David detectors. One of the important results he had shown here was that, number one, it is only in this uniformly accelerated frame that you have inequivalent quantization. For instance, if you have a rotating detector, rotating observer, the quantization is not inequivalent. But if you study objects such as responses of detectors, for instance, he analyzed the responses of detectors, there can be differences in the responses, and therefore you need to be careful in interpreting what you mean by a particle in a non-inertial coordinate system and a generic curved space-time. On a completely different note, this is somewhat different, not on the line of gravitation and quantum field theory I've been focusing on. This is somewhat different, but Paddy, I know, has been very proud of this paper. What he is interested in examining is the statistical mechanics of gravitating systems. For instance, if you have a collection of stars, which come into so-called virial equilibrium, how does one show that they do arrive at such an equilibrium? So what Paddy had shown in this paper is that, in this article, where the potential energy is dominant. This becomes important if you're trying to understand formation of globular clusters or even galaxies. And there comes an intermediate regime. In these two domains, specific heat is positive, but when gravity is present, you can expect specific heat to be negative. And there comes an intermediate domain where specific heat is negative, and this is where the virial equilibrium occurs. And there are nice, interesting results that arise as a consequence. These are, as I mentioned, this is he had written, if I recall correctly, in 1988, before he moved to IUCAA. The next thing, the intermediate years, he had worked on various aspects of quantum field theory and gravitation, as I will highlight. Oh, sorry, I moved a little too fast. I already mentioned as to how, if you integrate the conformal degrees of freedom, in an earlier paper, Paddy had shown that your sigma squared, x and y, denote two space-time points. Sigma squared is replaced by sigma squared plus LP squared. In 1997, I believe, yes, okay, Paddy had another approach to arriving at this result. That is, you have the propagator of a massless field is essentially 1 over sigma squared is replaced to 1 over sigma squared plus LP squared. What essentially happens is that if you are trying to write your Feynman-Green's function in the Schwinger's proper time formalism, what you have is that you have an integral ds that appears in the proper time formalism. He essentially replaced by integral ds plus LP squared by ds, and he could actually sum over the path integral. So what you do is that you write the standard Feynman propagator using the Schwinger's proper time formalism as a path integral of a relativistic particle. But you modify the action of a relativistic particle so that it goes from ds to ds plus LP squared by ds. And he could sum over all the paths to calculate the path integral and therefore the Feynman-Green's function. And what he could show using this so-called duality transformation, that is the action which is invariant under the duality transformation, you do obtain the original result that you had obtained by integrating over the conformal degrees of freedom. Unfortunately, I have not been able to understand, I do not know what was Paddy's understanding as to how can you establish the relation between this result from this so-called duality transformation, and the result obtained by integrating over the conformal degrees of freedom. This is something, so-called minimal length, effects of minimal length or the 0-point length. This is the reference to the paper I had mentioned earlier. So remember, he had integrated the conformal degrees of freedom to arrive at this result, amazingly using a completely different approach, what is known as the duality, using the so-called duality principle or an action which is invariant under the duality transformation, he was able to arrive at the same Feynman propagator, which exhibits this cutoff, so to say, at very small scales. We had gone on to understand, I have been involved, for instance, in examining the corresponding implications for various results in quantum field theory, such as the Unruh effect, or particle production in an electric field background, etc. Another interesting result which Paddy had obtained, which is well recognized in the literature, is was carried out by Paddy and one of his doctoral student, Srinivasan. Here, what they were interested in trying to understand particle production in a variety of space-times. For instance, if you are interested in the Schwinger effect, you can, the case of a constant electric field, as you very well know, you can describe it in, very different gauges. In a time-dependent field, you can define in states and out states and calculate the Bogoliubov transformation between the in states and the out states, and you can interpret this Bogoliubov transformation as particle production. But there is a challenge that arises when you are studying in time-independent gauges. Then you need to understand how particle production arises, and this can happen, for instance, if you are studying, evolution of a scalar field in a Schwarzschild metric or other metrics where there is a horizon, say, and you have a time-independent background. What Paddy and Srini showed was that you can choose something known as the complex path. Typically, you can reduce the problem at hand to an effective Schrodinger equation, and you have domains, you would think of a scattering problem, you have domains where the classical solutions are, classically accepted domains, and there is a classically forbidden region, and they provided a prescription of integrating the solutions across this domain and calculate the number of particles produced by such backgrounds, and this method of complex paths who's currently at NCRA, where they study this very popular tachyon model, which was introduced by Ashok Sen in the early 2000s. And what they were able to show that under certain conditions, they were able to utilize this tachyon model to explain both a smooth dark energy and clustered dark matter. And then with Jasjeet Bagla, who is currently at Isa Mohali, and Harvinder Jessal, who was a postdoc of Paddy at Ayuka, they went on to carry out a systematic analysis of tachyons as dark energy. And apart from here, they not only considered various potentials to drive the tachyon model, they went on to compare the models with the data, and later, this was in 2003, soon after, the WMAP data came in as well. So they carried out a systematic comparison of dark energy models with the various available data. These are again well-recognized work of Paddy and his co-workers in the early 2000s. And all these efforts led to this epic review of the cosmological constant, the weight of the vacuum. As you may know, the story is that the cosmological constant is still, consistent with what the available data. It was then, and it continues to be so. It remains to be so. And one of the challenges is to understand what is the origin of this cosmological constant. As you very well know, it is considerably different from the quantum gravitational scale, and the source of the cosmological constant is still a puzzle. So Paddy provided a few alternatives, some of which are currently considered standard, and he tried to use these so-called de Sitter spacetime thermodynamics to provide possible solution to the cosmological constant. But the issue still remains open. Now we move on to the later years. This is, Paddy has stopped worrying about the cosmological constant and he's moving into a new direction. And this is where he's trying to sort of invert the thermodynamic relations that is known in the context of Hawking radiation and black holes. As you very well know, if you have horizons, they are always associated with the temperature, and there is also an entropy as well. And there are these black holes satisfies the different laws of thermodynamics. What Paddy, motivated by other work just prior to this physics report article, were trying to essentially show that there is a one-to-one correspondence between Einstein's equations and the thermodynamic relations that applies to spacetimes with horizon. This was an initial review which highlights the resemblance of the spacetimes with horizons which have thermodynamic properties like temperature and entropy, and you try to relate them to Einstein's, I'm sorry, I moved too fast, to the Einstein's equations. Thereafter, he tried to extend, this was essentially focusing, the earlier review was essentially focusing on Einsteinian gravity. Then he was trying to extend it to other modified theories. In particular, as I will show in the next slide, he was studied this for the case of Lang's-Lovelock models of gravity, and this is around this time he started coming up with this idea of an emergent paradigm for gravity. The notion is that you have thermodynamics of spacetimes with horizons, and he has in mind where you have there is something like there are atoms or molecules of spacetime. If they have temperature, it essentially means they can be moving around, and what happens is that gravity is emerging as because of the, you can construct a kinetic theory of gases, something equivalent to kinetic theory of gases, describing the gravitational degrees of freedom, and which is what manifests itself as temperature and entropy. This random motion associated with possible atoms of spacetime. And what it essentially is, he was trying to say is that gravity emerges because of some microscopic motions of atoms or molecules of space-time. And therefore, he was trying to ensure that all these relations between the field equations of gravity, whether it's Einstein's gravity or modified theories of gravity, have a one-to-one correspondence between with the thermodynamical equations. And this was something he had, this was a review article he had written with my colleague Daud Kotawala, and this had focused on Lang's-Lovelock models of gravity. And a little later, he had extended, sorry, I moved in the wrong direction. A little later, he had extended to other theories of gravity. His plan was to, sort of solidify his notions of this emergent paradigm. The whole idea is that you need to understand what are the microscopic degrees of freedom which can, maybe you can construct a statistical mechanics of, which will be your quantum theory of gravity, but in the macroscopic level, they will essentially manifest as a classical theory of gravity. And this was, he extended with Sumanta Chakrabarti, who is currently at IACS, to the Eddington gravity, and he, this is sort of pushing the so-called emergent paradigm to other models, other theories of gravitation. So, as I said, I have tried my best to cover Paddy's contribution and some work with his students, on different aspects, largely related to gravitation and to some aspects of cosmology. In the remaining about 5-10 minutes, I'll make a few closing remarks. Paddy was, he always was passionate about physics, and his passion is, reflected in this preface that he has written in this book, Sleeping Beauties in Theoretical Physics. Let me read it for you. Theoretical physics is fun. Most of us indulge in it for the same reason as a painter paints or a dancer dances. The process itself is so enjoyable. Occasionally, there are additional benefits. like fame and glory and even practical uses, but most good theoretical physicists will agree that these are not primary reasons why they are doing it. The fun in figuring out the solutions to nature's brain teasers is a reward in itself. I think it reflects perfectly Paddy's reasons for pursuing physics. And I mentioned earlier that, Paddy in these 3 volumes tried to emulate the spirit of Landau Lifshitz as applied to the course of theoretical physics. And this thing clearly reflects Paddy's virtually relentless energy, what he has said here. The approach used in these 3 volumes is very similar to that used by Genghis Khan. Namely, cover as much area as possible, capture the important points, and be utterly ruthless. At HRI, when I was forced to teach, astrophysics, I had the opportunity to learn to a large extent volume 1 and to a good extent volume 2. I haven't done much of volume 3, I haven't done much of volume 2. But if you are an astrophysics student, I would really urge you to work through these 3. Not you don't need to necessarily be an astrophysics student, but if you're interested in astrophysics, I would strongly urge you to work through these books. This 2 comments by reviewers reflects Paddy's clarity in writing. He used to say, when I used to say, it's amazing, Paddy, that you're writing these books. It's simple, Sriram. Both about reading books and writing book, he used to say it's very simple. You just need to write 3 pages a day. In a year, you can write 1,000 pages. It's as simple as that, okay? And it's amazing. He will do that. He will, he can produce a manuscript overnight. So his clarity of thought and his mastery of the topics he works on was amazing. This is a review of theoretical physics written by Alan Hevans. The real estate that is referred to is the real estate of Genghis Khan. So what he writes is as follows. It is written with exceptional clarity, which is the hallmark of Padmanabhan's work, but the reader should be clear that in needing to conquer vast tracts of astrophysical real estate, prisoners are not taken and the pace is fast. To do this while still providing a book which is understandable and illuminating is a considerable achievement. The approach is rigorous and unashamedly mathematical, surely necessary to obtain proper understanding, and this volume will appeal to and challenge astrophysicists who wish to cement their knowledge through mathematics. It's a magnificent achievement and a superb book. It was tough for me to, this was my first course I was teaching in astrophysics. I recall working through volume 1. It was difficult. And I used to work literally until the last few minutes as I go to the students and I teach the course. But it has helped me, a lot in trying to sort of increase my intellectual stamina, as Paddy would say. This is a review by John Peacock, who's famous for his book on cosmology, on gravitation foundations and frontiers. There is immense erudition and mastery of both formal tools and calculational details, and it is really impressive that one individual can understand so much so deeply. I think these comments fairly reflect, Paddy's extent of understanding, his extent of knowledge, and the challenge as a student in keeping with him. I have not mentioned Paddy's family at all until now. Apart from that one instant where I mentioned the last book that Paddy had written was with Vasanti here. And this is Hamsa, who is carving her own place in, as a physicist. He's a cosmologist working presently at Geneva. And this is again a photo from this Malayalam weekly that I had mentioned earlier. These are pictures of Paddy with his students and grand students. These, I believe, were taken at ISA Mohali in 2019 when we had an ICGC meeting. A few years back, I believe in 2017, in April 2017, Paddy had come to give a talk at IIT Madras as a part of the Research Scholars Day. This is a picture of Paddy that I have in my office. It was taken, I believe, in in 2003 or 2004. It has been staring at me for almost 2 decades. I used to have it at HRI, I have it at IIT Madras. You know, the screen here tells you that he's working with pine, so you know the age roughly where it comes from. And you can see a picture of a tiger behind. You know, he used to like this picture. Paddy was amazing. You know, he was a force of nature. He was full of energy. He will call at any time and will start discussing physics, and you can do the same to him. Unless he's busy with something, he'll be immediately, you know, he will immediately start getting into discussions. He was unstoppable, unchallengeable, and unforgettable, much like gravitation that he strived all his life to understand. I should mention that I've consciously omitted a slide on Paddy's passing away. Though we do miss his physical presence, he continues to stay in our hearts and minds. I'm confident that Paddy's students, grant students, postdoctoral fellows, and all other researchers who have been influenced by him will carry his legacy forward. With those remarks, I will stop here. Thank you very much for your attention.
Hello. Thank you, Sriram. Thank you for sharing the brilliant life and research of Professor Thanu Padmanabhan. So we will now open the floor for questions, please.
Thank you very much. It was an excellent talk on our dear friend Padmanabhan. I just want to add to what you said. He was an extraordinary teacher, and his lectures were absolutely clear. Of course, from the old times, I have heard many lectures. And he would give a series of lectures to anyone who wanted to learn a topic. So in fact, I remember he gave a course on electrodynamics to just one student who happened to be my wife. And once when I went to call her, there he was absorbed in writing on the board, and he used to write with both hands.
Yeah.
You know? And he wouldn't mind teaching one person or, you know, a classroom or a hall full of people. He really loved teaching, and he was an extraordinary teacher.
Yeah,
Thank you very much.
Thank you, Professor Murthy. I guess you're referring to these late night teaching at TAFR, is that correct?
Yes, yeah, in that corner room he used to
I have heard of
Actually,
this.
in the students' room.
Yeah, I have heard about this from Kandu and others. You know, for want of time, and as I said, as far as the physics is concerned, my own limited grasp, I could not cover all aspects of Paddy. There are many aspects of Paddy I can talk about. You know, yeah, thank you for reminding me of one of them. Yeah.
It was very interesting to hear your comments about and also personal experiences. I just wanted to couple of comments and then one query also.
Sure.
The comments are essentially, he came to our meeting on Chandrayana in 2008 or so, and he gave an excellent talk following some of the things which you said about Avogadro's number of the space-time. This is a very interesting thing. And it was so exciting for him. He himself was excited about it, and he spoke about it. Stuff. Another comment, minor thing which I wanted to say is, in his early days, there was an interesting group of students from Trivandrum who formed almost a physics club or physics society.
Yes.
And all of them used to, and that played a major role in his own accelerated growth in physics at a very, very young stage. And they themselves, others were also very extremely impressed by the collaborations which were there. And the last thing actually I wanted to, the query is, because I didn't hear any mention about it, he worked with Jayant Narlikar, and I would like to know whether he had any specific comments about Jayant Narlikar's, at least initial stages, where steady state theory he was telling, and what Paddy felt about it.
I know that Paddy never worked on it. I should confess, I do not know why he didn't work on it, what was his understanding with Jen Narlikar. I believe he wanted to work on some of these aspects of quantum cosmology. Jayant was working just prior to this on quantum cosmology itself. You will see some of the papers cited in that book, in one of his first book. So I am not able to comment about why Paddy did not work on steady state theory or what his views were. The fact that he didn't work on it, I think, is a reflection. I think I'll leave it there. About the Trivandrum Society that you were mentioning, again, you know, this is well captured in this, you know, few-page article by Jasjeet and Sunu. It mentions how various things, including the Trivandrum Society, and in fact there are a group of 3 physicists who, you know, sort of motivated each other, you know, and reached great heights from Trivandrum. Yeah, and these are all well described there. So I was trying to take a completely different view, highlighting Paddy's work as such. Yeah.
But by long distance, his work with Jen Narlikar on avoiding singularities.
Sorry, say it again.
On avoiding singularities and therefore the Big Bang.
Right.
That might have had some influence of Narlikar's.
Yes, absolutely. His work on his thesis work on quantum cosmology was motivated by what Jayant Narlikar was working around that time. He had influence, but his question was about steady state theory. I think I should not comment about it because I do not know the details as to, I cannot speak on Paddy's behalf. Yeah.
My comment would be that he came too late for steady state. That was already out of fashion by the time he joined it. But I mean, what was his take on this conjecture of inflationary universe, which is very, did he have any particular opinion, or was he critical? Was he, I'm curious.
I work largely on inflation. Sorry? I think Paddy was ambivalent. He will say that with some of the comments I agree, it's not, okay. He used to say the following for sure: you do not need inflation to overcome the horizon problem. Because he used to say that if you want to define the horizon, you will have integral dt by a of t being the scale factor. If you don't know what's going to happen to a of t close to the Big Bang, you don't know what is the value of the integral. So it is not clear that you need inflation. But he has written reviews on inflation with Professor Narlikar. Okay, I should mention that, and I have a paper with Paddy on inflation. So I think he recognizes his book on gravitation discusses cosmological perturbation theory and generation of perturbations during inflation. So he recognizes the alternatives, you know, something like a bounce universe or a loitering universe can provide other solutions to the horizon problem. So he was not fixed on inflation, but I don't know whether he was extremely critical of it either. He would say that there are alternatives.
Was he, so he was not involved with this CCC, cyclic,
Cosmology.
conformal cyclic cosmology? Did he have anything to do
No,
with
I
Roger?
don't think.
Did he work on that?
I don't think Paddy was
He never worked with
studied
Roger.
on in a cyclic.
I think that's a one-man effort by Roger, probably.
Right. So no, I don't think he was interested. He has worked on it. I shouldn't say he was not interested in it. Paddy was interested in a variety of stuff.
Okay, I have a few questions,
Sure.
a couple of questions I could have asked later as well, but I think these are important for faculties and students and very relevant today as well. So as IUCA grew, there were many faculties joined in, and what was Paddy's take on taking students? It is very, based on the life. I mean, given people approaches him to be as thesis supervisor, how did he select?
Okay, I don't know how he selected. We used to make, his first student was TP Singh and Seshadri. His next set of students were Jasjeet and me. There was a Punjabi and a Tamil. So at least the first 4, there was something, but I think there was no such formula he had, and I think he would just, in my case, Jasjeet knew Paddy very well through Sage, who was at Delhi University. Jasjeet studied at Delhi University. I did not know Paddy before I left Chennai. Unfortunately, as I used to complain to Shyam, there were many people doing gravitation in those days in 1990s at Chennai. So I did not know about Paddy, but I recall very distinctly when I met Paddy after the interviews at IUCAA. So it was something, it was a process. I spoke to him, and then over a period of time he agreed to take me as a student. I think, I don't know whether he had a specific formula or expectation. One thing is that, two things is that you work hard and you be prepared. In those days we didn't have a phone call. Now with, mobiles everywhere, you be prepared for a phone call. I think if you, the only thing Paddy doesn't like is you not working hard.
Okay.
I don't know whether he had a specific formula to select students or a specific set of principles he would adopt. I think it comes by interaction, and over a period of time some relation develops and he agrees to take a student.
Okay, my second question is basically, second and last question is basically on research. So you showed 3 stages of research over which basically we came to know about the discovery of accelerated universe, and after few years, 3 or 4 years later, we have the WMAP data.
Yeah.
So Paddy has worked on those aspects as well with Tirthankar and other people. So did he try to work on cutting edge research? But afterwards he showed that he has changed his gear.
Right.
So he mainly devoted most of his time in cutting edge research or something that is long.
I don't think Paddy ever saw something as cutting or otherwise. If it's a problem, he will work on it.
Okay.
All problems are exciting to Paddy. That is what I have always observed. What he has done is that since, I think his last papers on cosmology are probably this Jasjeet paper. That doesn't mean he doesn't have papers on cosmology. Let me state it clearly. I know he had papers with Jasjeet students later, for instance, much later. I think his focus turned towards gravitation, particularly this relation between thermodynamics and, that is whether the Einstein's equations are exactly identical to the thermodynamic relations, whether there is a one-to-one correspondence, and if there is indeed a thermodynamic relation, whether, as I was trying to say, whether, like kinetic theory of gases, whether you can construct a, fundamental model with which TRG was also referring to, where gravity or the thermodynamic equations emerge in some manner as a manifestation of these microscopic degrees of freedom. This is a macroscopic manifestation of the microscopic degrees of freedom, and I believe, I should not speak on his behalf, I believe, I haven't thought about this much, I think he was hoping that these will provide him with clues to what should be the degrees of freedom you have to actually quantize if you want to arrive at a quantum theory of gravity. I think that took most of his time in the last decade and a half. He has studied implications. I know that he has a paper with Hamza about the implications of such arguments on, say, whether you can say what is, explain the current value of the cosmological constant, etc. Okay, but those were interpretations rather than a formal development, which will emerge. That is what he was working towards, whether you can have, he was investigating various modified theories of gravity, whether it applies in all modified theories of gravity. I think that is what he was working on. He wasn't working on cosmology per se. I don't think he ever bothered about whether it is cutting edge or something. For instance, when the dark energy, or the accelerated universe came up, he started immediately thinking about dark energy, and students like Tirthankar worked with him around that time, and I think all his thoughts about cosmological constant appears in that well-known report, physics report article, Weight of the Vacuum. So I think that dark energy results indeed drove him to work on those directions, but I don't think it is a knee-jerk reaction to work on something just because it is popular. He had his own agenda, And he will, for instance, if you look at his list of papers, suddenly he will start writing in, I remember in 1997, I know the student, Abhinav Gupta, he wrote about radiation reaction in electrodynamics. So I don't think he was so concerned about whether it is cutting edge or otherwise. He had the bandwidth as, to absorb, work on a variety of things with a variety of people at any given time.
Thanks, Sriram. Are there any other questions? Questions from students? Okay. So if there are no other questions, let us thank Professor Sriramkumar for this brilliant. Thank you very much.
Thank you, Dheeraj. Thank you. Sure.